Hello everyone. Today we are going to discuss about our project, which is to design and simulate a solar water heating system for a house. Myself Ananjan De and my partner Mohammed will discuss about our project today. In the contents page you can see there are four types in which we accumulated our project. The first part is literature review. The second part we did project sizing, modeling and analysis. In the third part we have system control design and analysis. And in the fourth part we have system dynamic simulations. In the first part, in the literature review, it is evaluated to comprehend the simulation of a single family house design. As we calculated that the heating water consumes nearly 20% of the total energy consumption on average. This paper describes the topic, the background and the development of the solar water heating system. Various parameters of MATLAB software are taken into consideration when designing of the system. Homer, which is a design model that can calculate the consumption of hot water, can also be utilized in this study. In the first research paper we took by Soteris, this paper presents a survey of divergent types of solar thermal collectors and their applications. The solar heating systems which utilize solar energy and their application depend upon the solar collectors. They vary as many types as flat plate, compound parabolic, evacuated tube, parabolic trough, etc. In the next page, you can see the comparison of the collectors that is taken from that paper. There are various types of collector types. There are absorber types. There are flat, tubular, and point types. There are concentration ratio and the temperature range. In the next paper we took, that's written by R. Srivastava. This paper describes the modeling of a typical domestic solar water heating system. The results of the simulations performed on a daily basis for a solar heating system, which is operated in Constantine, which provides hot water for heating and household activities. In the next paper by Isaac, this paper it describes the design of solar water heater which consists of a flat plate solar collector, a water storage tank, which is heated again by solar energy. Here we can see the design of the solar collector and the solar water heating system. In the next part of our project, we designed and simulated a solar water heating system for a house. Introduction is a solar water energy is used for heating water systems, and solar panels are commonly installed on building roofs to collect the solar energy. The temperature of the tank and the quality of the metal utilized are the two elements that affect the solar energy storage. The thermal energy storage can lower peak electric power loads in buildings, which also takes advantage of waste heat recovery and the renewable energy. Next, we did the research on solar radiation in Newfoundland and Labrador. This model is to design a solar heating system for a house in Newfoundland. So solar radiation was calculated using the Homer software program for a specific area. Homer software supplies inputs that characterize the technological options, resource availability, and component pricing to the model and simulation. In the next part, we have chosen the model location in St. John's, Newfoundland, and we designed the desired house where we should install the solar water heating system. The Homer software, it also calculates the solar radiation in theory. On an hourly basis, we know imported solar radiation data from NASA for the latitude 47.34 and longitude 52.40 as shown in figure. In the next part, we calculated Newfoundland and Labrador's annual solar energy. The annual solar energy, the value is about 3.15 kilowatt hour per meter square per day. This figure shows monthly average solar data from the Homer simulation. In this next point, there are solar water heating system components for closed-loop indirect system. The indirect solar glycol systems use propylene glycol or water glycol as the heat transfer fluid in the solar array to overcome the freezing issue. Because Newfoundland is a very cold area and we need different phase change materials to keep the solar water heating system running. The ethylene glycol water mixtures are separated from potable water using a heat exchanger that transfers energy from the array to the fluid in the storage tank. In the closed-loop indirect system, advantages is it gives good freeze protection, good hard water tolerance, and the disadvantages are there are higher cost to create an open-loop direct systems and high maintenance requirements. In the closed-loop indirect system components, the main components added to the heating system that is used are collector field with collector field piping and support structure, heat transfer fluid, a storage tank system, pump for solar loop, heat exchanger to transfer heat from one loop to another, and a controller. Here you can see the diagram of a closed loop indirect system for a solar hot water system. In the design parameters, the parameters for model design are hot water temperature, inlet cold water temperature, the average hot water consumption for one family, which is 200 liters per day, and the annual average value, which is about 3.15 kilowatt hour per meter square per day. The calculation we did of annual energy demand, where Q out is the heating capacity or output, Q is the flow rate, rho is the density of water, dt is the temperature, and Cp is 4.180. In the next part, we did the solar storage tank sizing. So the solar storage tank we took of 300 liters. This calculation helps prevent system water heating when the hot water demand is low. In the heat exchanger calculation, for efficient heat transfer, the heat exchanger needs 0.2 meter square of surface area per meter square of the collector. In the heat transfer fluid type, we took an ethylene glycol as mentioned as below as indicated by the freeze hazard. In this table, we discuss about the freezing point by Fahrenheit and degree centigrade for different temperatures of ethylene glycol. Next, we did the solar heat pipe pump sizing. This model is a closed loop model, so the centrifugal pump is the most suitable for desired application. There is almost no noise and is more suitable to use in a residential area, and there is no leakage in the pump. This is the cross section of a centrifugal pump. Here we did the calculation. Here we took these points like P is power of the pump, rho is the density of fluid, G is the gravity, Q we took as flow capacity, H is the differential head. Next, we did the water glycol pump. We assume the flow rate of heat transfer fluid is 0.5, and for different heat is 5 meters, and the type of fluid is water heater ethylene glycol. This is the summary we did for designing the solar water heating system. For the house, we can see the solar collector is 11.1 meters square in size. The storage tank is around of 52 gallons. The heat exchanger is shell and tube. The solar heat pump and the water glycol pump is a kind of pump which is recognized as centrifugal pumps. In conclusion, you can say that solar energy is a renewable resource and it is working on solar water heaters. It is very easy and simple to have hot water to use. People exactly do not need to heat the water before they use it. The solar water will work on itself and it can reduce the cost of living and such a lot of electricity bill, and it can save a lot of money. Thank you. In the next part, my partner Mohammed will continue. Thank you.
Hello everyone, I am Muhammad Af. I will start talking about temperature control system for our project. Actually, we are using cascade control system, which is often used to achieve smooth tracking with fast disturbance rejection. The most straightforward cascade architecture involves two control loops, inner and outer control. The inner loop is typically quicker than the outer loop to reject disturbance before propagating the outer circle. We are using our MATLAB software for this project and install cascade control loop to control the desired hot water temperature via measuring the hot water temperature inside the hot water storage which already is master PID controller, and measuring the temperature of the water mixture output from the solar collector slave PID controller, and based on the production of the slave PID controller error is controlling the speed of the solar pump speed from 0 to 100% of the nominal pump speed. We are using VFD variable speed drive to control the speed of the pump. For control the system, we have input and output signals, which already we're using and we simulate using the MATLAB. First, we have the output signals. We have two output signals. One hot water tank temperature sensor, RTD. We are using 420 milliampere. Second signal is temperature sensor RTD, resistant temperature detector, and we're also using from 4 to 20 milliampere. Here in this slide, we have in the left-hand side is 20 milliampere output transmitter for RTD to convert the RTD signal to 4 to 20 milliampere. In the right-hand side, we have the RTD input transmitter, which already is measuring the temperature from the tank and converts this temperature to resistance. The analog input signals, we have AC drive VFD, variable speed drive, receive 4 to 20 milliampere from the slave controller to 0 to 100 of the maximum pump speed. The controller, we use PLC Allen-Bradley model with analog input cards to control this project. During the simulation phase, we will using Simulink to simulate our temperature cascade control loop. The blue cascade control loop is simulated via Simulink, and we create the cascade control in Simulink to ensure the PID output response that is manipulated based on first, the hot water temperature required set point, actual temperature of the water gel mixture, isolation losses. This is considered it's vary from 5 degree to 10 degree. Also, we define P and ID parameter for both PID controller to get the best response as fast as to reach to the desired set point steady state, and the minimum they were overshoot during the transient period. On the other hand, two transfer functions have been created for both loops. Case 1, both controllers are PID with same parameters. Master PID and slave PID parameters are same, and the isolation losses was 0 degrees centigrade. Proportional is 1, integral is 1, and derivative is 0.2. Observation, we found there is overshoot around 9% from the temperature set point, which is already 55 degrees, and reached to steady state after 18 seconds. In this portion, we are talking about solar hot water system protection. There are two protection systems shall be implemented for the system to avoid any overflow, pressure, overheating, and protection in the winter season. We have two types of protection. The first one is electrical protection. The electrical protection in the system is interlock, connect the hot water pump with the level flow in the hot water tank. That once the level in the tank reaches the high level, automatically the hot water pump should stop and not run again till the desired water level reduced. Second is mechanical protection. Against the high pressure inside the system, we are installing BSV pressure safety valve in the hot water pipelines to avoid increasing the pressure inside the pipe due to the hot water. Pressure safety valves are also commonly referred to as simply safety valve. They are used to relieve pressure from equipment operation system. Generally, valve open suddenly and instantaneous. Our conclusion from this project: there are several reasons to believe that active and passive solar water heating systems are suitable for your home. The passive solar water heating system is reducing electrical bill in cold weather. It reduces harmful fossil fuels such as propane, coal, oil, and others. It's helped to eliminate air pollution and provide a clean living environment. The result of this project should encourage wide utilization of solar energy system, which will help in keeping our environment healthy and clean.